Hello friends, we are going to discuss the nodal analysis in which we will find out all the node voltages. After that we can calculate any current in any branch, any voltage across any resistor. Coming to the point, here is one complex circuit in which we have to calculate all the node voltages, or it is asked like that, what will be the current of this resistor. For calculating the current of this resistor, one method is nodal analysis, in which we will find out the node voltages. So to find out the node voltages, what will we do? I just wrote down all the procedure, but before I will just discuss here. So first point is, you have to identify total number of principal nodes. Principal nodes means that node which is connected more than two elements. This node is connected to more than two elements. This is your principal node. This node is connected more than two elements. This is your principal node. This node is connected more than two. This is principal node and this is principal node. So total number of principal node is equal to 4. In the next step, what will we do? We will take one principal node as reference node, and the reference node will be equal to ground voltage. Ground voltage means 0. Among 4 principal node, we can take any node as reference voltages. If you will take this, then there will be no difference while calculating the current in this resistor. And the next point is, develop KCL equation at all the non-reference node. If we have taken one reference node, let us assume we have taken this node as reference node and this is equal to 0, and this will be your non-reference node, and we can write KCL equation as at 3 non-reference node, and then we can calculate these voltages through KCL. Let us assume I1. We can take any direction according to ourselves. We need not to worry about the direction of current while calculating the node voltages. This is I1, this is I2, this is I3, this is your I4, this is your I5, this is your I6. No, this is not I6, this is I3. This is your I6. At any node we can write down the KCL equation like this. This is your first, this is your second, and this is your third. At second node we are writing the KCL. So incoming current is what? Only I2, and outgoing current is what? I6 and I4. So writing down the KCL equation, I2 will be equal to what? I4 plus I6. And further, the value of I2 we can calculate. The value of I2 will be equal to what? The value of I2 will be equal to V1 minus V2 upon 2. V1 minus V2 upon 2 is equal to V4. I4 will be equal to V2 minus 0 upon 3. V2 minus 0 upon 3 plus I6 is equal to V2 minus V3 upon 1. V2 minus V3 upon 1. This is how we can calculate the V1, V2, V3 while writing the KCL equation at node 1, node 2 and node 3. I have written down all the necessary procedure whatever required to calculate the value of V1, V2 and V3. The nodal analysis is what? Nodal analysis is your KCL plus Ohm's law. This question has been asked in your GATE examination, so keep in mind what is your nodal analysis? KCL plus Ohm's law. So this was the procedure. We have studied the procedure of your nodal analysis. To understand in a better way, we will understand this with one example. These two circuits are exactly identical and we have to calculate the value of V0 in the both circuit. It means the question is same. We will do by taking the current direction. This circuit I am taking current direction like all the currents are in outward, but in this case we are taking this your I1, this your I2 and this your I3. Here we will see the procedure. First we have to calculate the number of principal node. So the total number of principal nodes are what? 2. Here I am just solving this. After that I will solve this. In this question we have two principal node and one principal node will be given as taken as what? V reference is equal to 0. So this V0, and I have taken the current direction, all the three current direction outward, I1, I2 and I3. So writing the KCL equation, your I1 plus I2 plus I3 will equal to 0, and the value of I1 will be what? I1 will be what? V1 minus 0, V1 minus 0 upon, this is your first node, this is your second node. Just I have discussed this in KCL. So value of I1 will be equal to V0 minus V reference means 0, V0 minus 0 upon 3, and this voltage source is supporting I1, it means plus 1, plus I2 will be equal to what? V0 minus 0 upon 2, V0 minus 0 upon 2, plus I3 value will be equal to V0 minus 0, V0 minus 0. This is opposing the I3. This is opposing the I3 means minus 5 upon 1 is equal to 0. So we can calculate V1 plus 1 by 3 plus V0 upon 2 plus V0 minus 5 upon 1 is equal to 0. Multiply by 6. This will be equal to 2V0 plus 2 plus 3V0 plus 6. 6V0 minus 30 is equal to 0. So 2V0, 3V0, 6V0. 6, 3, 9 to 11. 11V0 will be equal to 28. So V0 is equal to 28 by 11 volt. And here we have to calculate the value of V0. Only difference I am taking is I1, direction of I1, I2 and I3. I want to show that there will be no effect of current direction whatever we are taking. And this was one example and this is other example. The question is same. Our method is different. So I1, I2, I3. In this circuit, when we will write the KCL equation, then it will be equal to I3 is equal to I1 plus I2, and that will be I3 is equal to your 0 minus V0. 0 means the current direction is, see guys, from V reference to V0. So it will be 0 minus V0 plus 5. Plus 5 upon how much? 1 is equal to value of I1. I1 means this is your V0 plus 1, V0 minus 0 plus 1 upon 3, plus I2 value will be equal to what? V0 minus 0 upon 2. So we can calculate from here and we can directly multiply 6 in left hand side and right hand side. So minus 6 V0 plus 30 is equal to 2. 2 V0 plus 2 plus 3 V0. So we will be sending this to this side and this 2 to this side. So it will be 11 V0 and here it will be 28. From here we can see that V0 is equal to 28 by 11 volt. In this question I have told you two things. First one is procedure how to solve the nodal analysis, and the second one is whether we are giving any direction in the circuit, it doesn't affect on the final result. Let's better understand nodal analysis with few examples. This is example number 1. In this question we have to calculate the value of E naught. Before understanding this question, I have to discuss some of the points. Let us assume we have one voltage source here. This is grounded, and this is your V1, and this is your what 10 volt has been written. So what will be the value of V1? Directly you can calculate V1 minus 0 is equal to what? V1 minus 0 is equal to 10 volt. So V1 is equal to what? 10 volt. If there is resistor here is one resistor, and it's been written as plus minus E naught, and this point is your V2, and this point is your 0 volt. We have to calculate the value of V2. Then what will be the value of V2? The value of V2 will be equal to V2 minus 0 will be equal to E naught. So V2 value will be what? E naught. We will apply KCL at non-reference node. So this is your principal node, this is your principal node. This will be treated as your V reference is equal to 0, and this will be your what? If this is your 0 voltage, then this will be your what? E naught, and this value we have to find out. And we will take the current direction randomly, I1, I2, I3. I am taking outside, then there is no need to worry, the answer will be same. The KCL is I1 plus I2 plus I3 is equal to 0. The value of I1 will be how much? E naught minus 80 upon 12. E naught minus 0, and this 80 volt is opposing I1. So E naught minus 0 minus 80 upon how much? 12. Plus the value of I2 is equal to E naught minus 16 upon 6. E naught minus 0 minus 16 upon 6, plus the value of I3 is equal to E3 minus 0 upon 12. E3 minus 0 upon 12 is equal to what? 0. So taking the 12 LCM, what it will be? E naught minus 80, 6 to the plus 2 E naught minus 32, E naught, 2 E naught, E naught. This is 4 E naught minus 80 minus is equal to 2, and 8 3 11. E naught, 4 E naught is equal to 112, and E naught value is equal to 112 upon 4. It means 28 volt. So E naught value will be what? 28 volt. So this was the first example. Here is the second example. In this example, we have to calculate the value of R, and all the information has been given, and we have to calculate also through nodal analysis. So we will apply the procedure of nodal analysis. This is your two principal nodes, and one will be taken as what? Reference node. And this direction is I is equal to 2 ampere. And see guys, here this is your given as 10 ampere. So you do not need to write like I is equal to V1 minus 0 upon something, because directly it has been given as 10 ampere, and this is your current source. And any current source value will be same whether the resistor is here is 5 ohm or 1000 ohm. Here it is directly 10 ampere source, 10 ampere will be here. 10 ampere is here and it is diverting 2 ampere here, then this branch will be having 8 ampere of current directly. We can see, or you can calculate with KCL also. So 8 ampere is here, and let us assume here is one voltage E naught. So 8 ampere will be written as 8 is equal to written as E naught minus 0 minus 40. So I am avoiding 0. directly I am writing 8 is equal to E naught minus 40 upon 10. So here we can calculate the value of E naught. 80 is equal to E naught minus 40. So E naught will be how much? 120 volt. And what the question is asking? The value of R. So no doubt guys, this is your V reference is equal to 0. So I will be written as what? E naught minus 0 upon R. I is equal to, that is your 2 ampere, will be written as what? E naught minus 0 upon R. So E naught upon R. So 2 will be given as your E naught. E naught means 120 upon R. So R value will be how much? Your 120 by 2, that is equal to 60 ohm. This is example number 3, and in this example we have to calculate the value of V naught. The question is calculate the value of V naught. So our first procedure is to find out the number of principal node in the given circuit. How many number of principal node in the given circuit? Only two principal nodes are present in the circuit. This and this is one principal node. This and this is one principal node. Do not confuse, because there is no resistor present in between this. So there is two principal node. We can draw also like this. You will understand easily. This is your V naught, and this is your 2 volt, 1 ohm, 1 ohm, 1 volt, 1 ohm, 1 ohm, 1 ampere. Here you can see easily we have two principal node and one will be taken as what? Reference. So V reference will be equal to what? 0. So we have to calculate only V naught, and this is only non-reference node, so we have to apply one KCL only. So the current direction is important right now. I1 is given as inside, so do not need to change this current source. This will be your I1, this will be your I2, and this will be your I3. And only 1 ampere is incoming, and all the I1, I2 and I3 are outgoing. So it will be written as incoming current is equal to outgoing current. So incoming current is 1 ampere and outgoing current is what? I1 plus I2 plus I3. And 1 is equal to I1 value is how much? V naught minus 2. V naught minus 2. V naught minus 0. I am neglecting 0. V naught, this is opposite. 2 volt is opposing I1. So V naught minus 2 upon how much? 1 plus I2 value is V naught, this is 1 volt, minus 1 upon how much? 1 plus I3 value will be equal to V naught upon 1. 1 is equal to 3 V naught minus 2 1 3 3 2 3 V naught minus 3 is equal to 1. So 3 V naught is equal to how much? 4. V naught is equal to what? 4 by 3. This is the example number 4 we are solving. In this question, the value of R1 and R2 we have to find out, and this question has been asked in GATE examination for 2 marks. So before solving this question, I want to discuss few concepts here which will help in solving this question. If this is your 10 volt, this is your 0 volt, so what will be the value of E? Directly we can see that E minus 0 is equal to 10 volt by applying KVL. So E value is equal to what? 10 volt. But if it is written here like this, this is your 0 volt, this is your 10 volt, and this is your 2 ohm, and this is your E. And the current is flowing. Any current is flowing, like either upward or downward. Let us assume downward. Okay. So what we'll see, if we will applying I, if we will be writing I, then what will be the value of I? The value of I will be equal to what? E minus 0, E minus 0, and this 10 volt is opposing this current, so minus 10 upon how much? 2. So the value of I is equal to E minus 10 upon 2. And what we have to find out the value of I. So the value of E will be equal to 2I plus 10. So we cannot directly say that the value of E here is 10 volt, because here is one resistor present. But in case of here, when there was no resistor, then directly we can write here as 10 volt. But we cannot write here 10 volt because here resistor is present and the current is flowing. If current is flowing, if the current will not flow, then the value of I will be 0 and the I E will be equal to what? 10. In the same way, if it has been written 10 volt upper and 2 ohm below, then if this is 0 volt and this is E, then same, the value of E will be same. The value of E will be equal to 2I plus 10 in the same circuit. It doesn't like if this is 0 volt and this is 10 volt has been written upside, then if this is positive, it means this 10 volt. No. For the entire two node system, we have to check whether the current is flowing in any resistor, then it cannot be equal to directly the EMF value. Coming to the question, I have discussed the basic here, how to solve this question. So here we have four principal nodes. We have four principal nodes, and after getting four principal node, we have to take one reference node. So this is your one reference node. This is your reference node. V reference is equal to 0, and if this is 0 and this is 100 volt and there is no resistor in between these two nodes, so directly we can write this 100 volt, this node voltage is how much? 100 volt. In the same way here, it will also be equal to what? 40 volt, because if this is 0 volt and there is no resistance in between them, then that will be equal to 40 volt. And the current will be flowing, if we will see 10 ampere is here, it means 10 ampere is here. 5 ampere is here, it means 5 ampere is here. When we will apply the KCL, then the current of 15 ampere will be here. Means 15 ampere is coming and it is diverting into 10 ampere and 5 ampere, and the current is flowing from upward to downward. Then we know that the current enters at the point that will be your higher potential, and the current leaving the resistor, that will be your lower potential. And the value of resistance is 2 ohm and the value of current is your 15 ampere. So this drop will be your 30 volt, and here it is 0 volt, it is 0 volt, so directly we can write here as 30 volt. It is easy, and in this way we can calculate the value of current in this branch. The value of current in this branch will be how much? This will be equal to 100 minus 30 upon 14. 100 minus 30 upon 14, it means 70 upon 14, it means 5 ampere. It means 5 ampere current is flowing here, and here it will be your what? The voltage is 40 is here and the 30 is here. It means we can understand that the current will flow from 40 to 30 volt side. So we will assume the value of current is your I2. This I2, and this your I1 in this direction, because this is 100 volt and this is 40 volt and this is I1. So now we can apply the KCL. at this node we know the value of voltage is equal to 100 volt. At this node we know the voltage 40 volt. We will apply the KCL at here, and correspondingly by the help of these voltages we found out the value of current in this and current in this, and the voltage drop 30 volt across this. So applying the KCL, 5 ampere plus I2 is equal to what? 15 ampere. 5 plus I2 is equal to what? 15 ampere. So 5 plus I2 will be what? I2 will be 40 minus 30 upon R2 is equal to 15. This will be equal to 10. So 40 minus 30 upon R2 is equal to 10. So this 10 upon R2 is equal to 10. So the value of R2 is nothing but R2 is equal to 1 ohm. R2 is 1 ohm, and there is 1. We have to calculate the value of R1. This is the value of R2 is equal to 1 ohm. We calculated. Now we have to calculate the value of R1. So what we will do, we know if this is your 10 ampere and from 10 ampere 5 ampere is here, then the value of 5 ampere will be here. It means the value of I1 is equal to what? 5 ampere. So the value of I1 is equal to what? 5 ampere. And we can write also the value of I1 is equal to what? 100 minus 40 upon R1. So 100 minus 40 upon R1 is equal to 5. So the value of R1 is equal to how much? 60 upon 5. That will be equal to 12 ohm. So the R1 value is 12 ohm and the value of R2 is equal to how much? 1 ohm. Thank you.